Question 7, we've got two position vectors, A and B, given their component values here, and they're both in reference to a fixed origin O. First of all, we've got to find the vector AB. So we need to travel along AB. So if we're going to travel along AB, and this, let's pretend, is the origin, I have to travel backwards to the origin from A and then go out again to B. So we've got to add the components up, but because I've gone backwards to O, the journey I've taken will be the negative version of the components here. And I can do this in column form. So the first bit of my journey will be the negative versions of these guys here. So this will be -2, +3, -5, plus the positive versions of these, which is 5, 6, and 8. And if I add them up, I get this column vector as the answer. And if you wanted to convert back to ij's and k's, that will be the answer. But this is a perfectly good answer on its own. And that's the end of part A. So part B, and I've cleared the decks for part B. We're now given a point P such that the distance from A to P is twice from B to P. So we need to find a point along AB that the journey from A to P will be twice the distance from P to B. So that's going to be about here, where this is 2/3 of the journey from A to B, and this is 1/3. And we know the journey from A to B because we've worked it out in part A. So P will be given by the position vector of A, which is 2, -3, 5, plus 2/3 of the journey we've done A to B, which is 3, 9, and 3. So we get 2, 6, 2. And if you work that out, the column vector turns into 4, 3, 7. So that's now the position vector of P. Now you might think that's it, but there's another point, P2. Now if I do the journey from A to P2, I can arrange it that it's double the journey back to B. Notice these modular signs here. It doesn't matter what direction we're going in, it's just the distance we travel. And the distance from A to P2 can be double the distance from P2 back to B. So the distance here, again, will be the distance from A to B, which is the value we found in part A. So we can set up another similar equation and get P2. There's the answer to P1 now. So P2, well, P2 again will be A, which is 2, -3, 5, plus, well, effectively 2 lots of this. And if you work that out, you get a column vector of P2 being 8, 15, 11. And those are the answers for part B.